Hi there. This is homework 4, um, which looks into um, not transforming, adjusting the chip planner. So initially, a part of the homework was to look at certain resources utilized. So we just import the Verilog or VHDL files and synthesize it. Um, that's what we're gonna do. So it's already synthesized. So the values for I have to look again. For the ALMs, flip-flops, IOs, DSPs, and BRAMs can be looked over here. So let's look at them. So for the ALMs, as we can see over here, is for the logic utilization. So all we have to go do is go to uh, fitter, place, and route under resource section, resource user summary. You can also use the summary from the fitter. This will also work. So if you see here, we can see that the number of ALMs for logic utilization is around 49. Um, After that, we also have to look at the number of flip-flops. So the number of flip-flops is the total number of registers, which is 77. Then we have the number of IOs. So let's look at that. They total bits 241 bits, so that's there. DSPs, DSPs 0 DSPs, and finally we have to look at BRAM and DLLs. Okay, so BRAMs are basically block memory bits, which is around 0, and DLLs right over here is 0. You can also look at the resource uses summary and gives you an in detail explanation. We want to look at logic utilization for ALMs, not these. Yep, that's pretty much it. Then, in order to see the maximum frequency, uh, all we have to do is go to Tools, open Timing Analyzer. Okay, so we're right here, Timing Analyzer. So let's look over here. So we scroll down all the way down to the data sheet option and under tasks. So under task, data sheet, and report Fmax summary. Give it some time. Yep. Okay. You can see this. So it is 276.01 megahertz from clock 50. So that should be it. Now to find the top 5 longest critical path, what we do is we go here. You just scroll down to custom reports, report timing, and you want to change this value to 5, right? So this is very important. This value must be 5. And then what you want to do is scroll down, report timing, and that should, I believe, give you the report. Yes. Yep. So these are the values. So we have the slack and we have the delay over here, right? So top 5, and we have the slack. We have positive slack with a time period of 20 nanoseconds. So now let us look at something else. So let's look at the other part of the homework, which is, okay, now we have to change the synopsis diagnostic constraint file, the STC constraint file, and we have to edit the time period to 2 nanoseconds. Instead of which was initially 20 nanoseconds, we have to change it to 2 nanoseconds and then report the same timing for the top 5 longest critical path, and let's see what impact does it make. So to do that, all we have to do is we can close this now, this timing analyzer. We can go here, and if you see this, if you imported this, the DE1-SoC.stc, you can open that, and we can change all of these to, sorry, and okay, and then you want to press Control S, save it, right? And then we want to resynthesize this, and compile it. So gonna look. And we're gonna wait. So I'm gonna pause until it's done, and then we'll come back. Alright, so the simulation has been done. Took a pretty long time, 6 minutes. So let's go to the timing analyzer. You can go to Tools and then Timing Analyzer, or you can just click this logo right here. Okay. Yeah. The same like before, we go to Tasks, and then we scroll down to Custom Reports, then Report Timing. Right. See how long this takes. So again, same as before, 5 for the 5 longest paths. Report timing, and we should be good. Right. So let's go here. So yes, so this is going to be our, yep, this is going to be our slack and our delay. So we can see there's a difference in slack, which is not good. We don't want negative slack. We never want negative slack. These are the critical paths, which has reduced significantly. I don't think they've reduced. I think they're more or less the same. Yep, they're more or less the same. It's just the slack has decreased quite significantly, and we don't want negative slack. All right, so now let's go to the next one. So part 2 is chip planner. Okay, so here we need to reset our constraint file, or what is it called again? I keep forgetting. It's called synopsis design. What is it called? Synopsis design constraint file. Yes, okay, I was right. Fine. We want to change this, the STC file, back to 20. So look at that. 20 to 0, 0, 0, 0. Okay, Control S to save, and we just run this again. Let's see how long it takes. So again, I'm gonna pause and then come back once the compilation is done. So pause. Okay, so now we're done with the simulation. Let's have a look. Took us about 4 minutes, 45 seconds. And not simulate, synthesize? That would be the right word? Correct. Okay. Again, now this is the chip planner part. I believe it should be the same. So timing analyzer, again, click that. Once again, need to close this first. Let's do that again. Timing analyzer. Take its time to open. There we go. Now, again, custom reports under the task options, report timing. Again, 5. So report number of paths 5, and then I want to scroll down, report timing. Should be there. Yeah. Right, so that should be it. So now what we want to do is click the first one, right? And we want to make some changes on the chip where the flip-flops and registers are placed. So for this one, so for this particular one, we want to see, for example, it's from this node to this node. We have a certain delay, and we want to basically change the positions of the flip-flop and registers for this particular one and see how it affects the critical path. So we right click on this, go to locate path, locate in chip planner. All right, give it some time, it's loading. Cancel. Okay, so let's do, okay, so this is our chip planner. Everything here. So what I do is there is an option right here to zoom in. I think that's a zoom in, zoom out feature. You can use that. If you have a mouse, what I found useful is just press your control button and zoom in. So for Windows, control and zoom. Control and just scroll your, I don't know what the scroller is on the mouse. I don't know what that's called, but whatever that is. So just scroll it. I do that. It's much easier. And then you want to go where you see these things are highlighted, because if you scroll up you don't see much that's highlighted, so use that. So scroll in right there. I think it has to do with this chip, right? So if you want, the best other option is, so you can do this, click this plus button and the zoom in button, go over here, and then you can highlight across that, just that portion if you like. I'll do that. There you go, you got a zoomed in version, right? Looks cool. So what my plan is right now to do is let's get rid of the zoom button. What my plan is to do is to move this flip-flop to the top of the chip and move this register to the left bottom corner, right? So this one to the top and this one to the left bottom corner. So somewhere over, yeah, oh sorry. Okay. I believe the flip-flop goes straight up ahead over here, somewhere on the top, and registers over here. Okay, so let's go into it. Let's see. Okay, so given that, to move it, you first want to do this, which is you want to click this and change it to assignment. So this will be editing mode right over here, right? Correct. And then over here, you want to click this arrow button. Because you initially click this, the zoom, so you want to switch out to the arrow, which helps you select. Now, what I would do is I would go over here, zoom in, zoom in, zoom in. Okay, I would click that. All right, so that is it, and you can see. And then what you want to do is zoom out. This is what I do personally to save time. Zoom out a bit, zoom out enough. Is that enough? That's enough. Okay. And then I just drag it to the top, and it's gonna wave. Helps it to move much quicker. Just drag it to the top. Drag it, drag it, drag it. It's gonna be a while, for long. Patience, patience, patience. Okay, here we are. And I'll just assign it over there, right over there. Right? Okay, so let me zoom in. And here is the flip-flop. Right, so there it is. And its location, not sure, should be here. I don't know why it's not showing up there. It should show up here, but device property something. No idea. But okay. We move that to the top, and I'm gonna take a register right now. So I'm gonna scroll down, and there is again zoom in. So I'm gonna take one of these registers, which is this. I'm gonna move it to the bottom left corner. So let's click on that. Zoom out a bit. Zoom out as much as you can. Zoom out. Zoom out. Zoom out. Okay, can I click that? Okay, fine. I can take that. Then what I do is I just go this way. Okay, there we are. I want to assign it to somewhere over here at the bottom. Hopefully that works. Did that work? I don't think that worked. Did that work? Which one? Okay, let me see this. Move to the side. I think it's here itself. What moved that? Nothing moved? I don't think I moved it. Oh, it's still there. Did I really move this? Let's see. Come on, go ahead. Go ahead. Go ahead. Go ahead. Okay. So let's put it here. Okay. Hopefully that worked. Oh, yep. Okay, that worked. So you can see this. This is the register, and you can see its location over here. So this is its old location and its new location, I believe. Okay. Fine. Let's close chip planner now. So I'm going to do that. Let's close chip planner and close this. And let us resynthesize again. So let's do that. And now I will pause again till the simulation is done, or the compilation. Okay, we're back. Synthesizing is done. Compilation, simulation, whatever. Now what do? We go to tools. Again, timing analyzer. You know the drill. Go there. Okay, here we are. Now, again, let's go through the steps again. Custom reports, report timing. Okay, that's good. Again, 5, and then report time. Let's see. Okay, so did the slack change? Yes, it did. All right, so 1 minute. So earlier, if I'm not mistaken, the slack was 16 something, which let me confirm on my sheet. Should have been 16. What was the slack? Yeah, 16.377 nanoseconds. So the slack has dramatically decreased, and the delay, the critical path, has significantly increased in all 5 cases. We can see that. Also, the critical paths have changed, meaning the initial node and final node. I think, if I'm not mistaken, in the previous case, before editing the chip planner, I think this one, the 5th one, had the highest critical path. Now it's somewhere over here. Now it's this. So this had the highest critical path in the first case. Now it's shifted to something like this. Okay, and this is entirely new. But let's look at this. Let's not take my word for it. Let's look at the chip planner. So same as before, right click, locate path, locate in chip planner. Alright, let load, give it time. Okay. When can I say abracadabra? Ah, it's here. Okay. It's right there. It's right. And 3, 2, 1. Okay, I'm good. Okay, so there we go. So you can see the